So you just received your MAX34417 EV kit and you want to know how to get it up and running? Stay tuned, I'll show you how. Hi, I'm Alec and I manage the MAX34417 power accumulator. The MAX34417 essentially measures the voltage across a sense resistor, the current flowing through the sense resistor, and calculates the power consumed by it. It also accumulates the power value over time. Today we're going to set up the EV kit and show how easy it is to get up and running. You probably received the EV kit in a box similar to this, and the EV kit is actually inside another box inside this box. We're not going to open it and go through this box because I have one set up right here on this table. You want to set it up on a non-conductive surface to make sure nothing gets shorted out. You also need a power supply capable of supplying anywhere from half a volt to about 20 volts and capable of supplying currents of up to about 3 amps. You need a DMM or multimeter to measure some test point voltages. You need, of course, a power resistor. In our case, it's a 10 ohm power resistor. You also need the supplied USB cable, which we are going to connect to the computer. Before we do that, we need to download the software from our website. It's called the MAX34417 Power Accumulator EV Kit software. I have already downloaded it and installed it, and so we're not going to go through that process. Next I'm going to do is connect the USB cable to our computer. You will notice that this top LED turns green when power is provided by the USB cable, and this LED here in the middle actually in the beginning flickers till a connection is established. And we can see on our software that it says it's connected mode and the EV kit is connected. Now before we connect power to the power resistor, let's check a few things. Confirm that our board, even though our LEDs are lit up correctly, I want to make sure that our voltage levels are correct. The board is currently powered through the USB cable, and I'm going to check to see that at our 3.3 volt test point we have about 3.3 volts. That's correct. In our 5 volt test point we have about 5 volts. We have 5.1, and that's correct. We also need to make sure, actually, that all the jumpers here, J3 through J22, are all plugged in correctly, and that our switch S2 is to the left and S1 is to the right. So I think we've got everything connected. Of course, let's not forget about connecting the power supply to the power resistor. And we have 4 channels of power accumulator feeding into the same device. And so we're going to connect each side of the power resistor to one of the channels. In this case, looks like it was connected to channel 4, but I want to start with channel 1. So we've got the power supply connected to the power resistor, and then the power resistor connected to the inputs of our power accumulator. So let's turn on the power. And we've got 4 volts connected across the power resistor. And first thing also we need to do, make sure in our control registers that the correct sense resistor value is put in. We've got a 10 ohm resistor, shows 10 ohms for all 4 channels. If that was, if our value of the resistor was different, we would need to change this value to make sure that our multiplier inside is correct. So now we go into auto poll mode, and as you can tell, it is reading our channel 1, which is in blue. It is reading 3.96 volts and 2 watts of power. There's a little bit of a drop through the cables, etc. So that's why this shows 4 and this is reading very close to 4, 3.97. Now to see what happens if we increase our voltage a little bit, let's go up to 5. And of course the GUI will react and so will our table at 5 volts, and now we're consuming 3.2 watts of power. We can go up, we can go down. We can also try some of the other channels. Here's channel 2. Blue goes to 0, of course. Channel 1 goes to 0. Red is now at 5 volts and 3.2 watts, almost. Channel 3, that's our green channel. Again, 5 volts, 3.2 watts. And then finally, our brown channel, 5 volts, 3.2 watts. We can go much higher, as you can tell, and much lower. The MAX34417 is capable of reading sense voltages of about 100 millivolts, or from half a volt to about 20 volts. That's how easy it is to set up the MAX34417 EV kit. Thank you for your time.